In Chapter 14, Exercise 15, the question is asking you to draw the amide formed in each of the following reactions. First, let's talk about what an amide is. An amide is a functional group. The functional group is when you have a carbon double bonded to an oxygen, single bonded to an amine. So this is not an amine. This whole thing all together, carbon double bonded to oxygen, single bonded to an amine, is an amide. Now, you can make amides by taking a carboxylic acid, carbon double bonded to oxygen, single bonded to an alcohol, and reacting them with amines, so nitrogen with just all three single bonds around it. This particular type of reaction ends up being really important because this is how amino acids are going to connect to form proteins. The acid, it refers to a carboxylic acid, and the amine refers to, or the amino refers to an amine. And so one connects to another through this very same reaction. One amino acid connects to the other to create all the proteins in our bodies. So that's the significance for this reaction. Now to draw this, my first step is I'm going to redraw the molecules in the skeletal structure. To me, that's just easier to see. So I have two carbons there. I'm going to draw that. Now notice I have these two carbons. The double bond to oxygen and the single bond to OH is on carbon number 1. And then here I'm going to have that NH3. Okay, so those are my two molecules. What ends up happening here, let me draw these in different colors. And I'll actually draw these three hydrogens out. So what ends up happening here is the OH on the carboxylic acid and the H on the nitrogen end up leaving and forming water, HOH. Right, you can see that right here, HOH, which is really just water, H2O. So those go away, and the carbon that had the double bond to oxygen just connects directly to the nitrogen in its place. Now you don't want to leave that awkward, extremely long bond there, so you can redraw it. And that is now an amide, because you have a carbon double bonded to oxygen, single bonded to an amine. That is an amide. By reacting a carboxylic acid with an amine, you created an amide, and this is the product of that reaction. It's true, you'd also get water, but the main product is the amide. That's what they wanted you to, that's what they were asking for you to draw in the question. Let's see how that works. Now these reactions are really all going to be the same process. The only difference are the carbon chains coming off of either the carboxylic acid or the amine. So in this case, let me redraw these as skeletal structures. So I have two carbons there. That means I've got those two, double bond to oxygen, single bond to OH. Right, just to be sure, I've got that 1, 2. Then on the nitrogen, I'm going to have 1, 2. So let me draw that nitrogen. I'm going to draw the hydrogens with individual bonds to them. So I've got that there. And then the 2, there's 1, 2. 1 and 2. Okay, so those are my two molecules. Now, I can, in these reactions, the OH from the carboxylic acid and the H, one of the H's from the amines, leave to form water, HOH, or H2O. Then, the bond that was going to the OH now just goes to the nitrogen. You don't want to leave that awkward long bond there, so you redraw it. And that would be your product. Now you'd also get H2O, but they're asking you for the amide that you form. And so this is an amide because it has that carbon double bonded to oxygen, single bonded to an amine. Let's try it with these molecules. It's really the same procedure, we just have different carbon chains coming off of the functional groups. Let me redraw these as skeletal structures. So we've got this benzene ring here, and then the carboxylic acid. That's benzoic acid, if you remember, benzene derivative. And for the nitrogen, I'm just going to draw the nitrogen. We have 1, 2, 3 carbons coming off of it. So let's see, 1, 2, 3. And I'm going to draw the hydrogens individually coming off of the nitrogen, so it's really clear and easy to see. All right, 1, 2, 3. Okay, so these are our two molecules. The OH from the carboxylic acid and the H from the amine leave to form water. So those go away. And the bonds that were going to those things instead just connect to each other. Now you don't want to leave that kind of funky looking long bond there, so you redraw the molecule. And that would be the amine that you would get when you react these two compounds. If you wanted to be fancy, you could say that's the amine you get when you react benzoic acid with propylamine.